The last section that we are going to look at in terms of graphing linear equations is going to be special cases. This comes from section 3.2. In order to be able to graph these lines, you will need to be able to find points by using a table and be able to plot points in the rectangular coordinate system. Upon completing this presentation, you will be able to recognize and graph vertical and horizontal lines, as well as recognize and graph lines that go through the origin. So we have three special cases that we are going to consider. The first special case is a line through the origin. A line through the origin has an x-intercept and a y-intercept, but they are the same point. They are the origin. Equations of this form can be written as y equals mx. Notice that there is no constant term. The second equation that we're going to look at, or the second line that we're going to look at, is a vertical line. A vertical line is straight up and down, like the walls in the classroom. It has no y-intercept, unless it is the y-axis, and then that's a whole other ball of issues we have to deal with. The equation of a vertical line is of the form x equals k, where k is some number. For these lines, note that there is no y in the equation, and there is no y-intercept. The last type of special case that we are going to look at is horizontal lines. Horizontal line is a line that is flat. For instance, the floor of the classroom, or the ceiling of the classroom, or the top of your table. These are considered horizontal. A horizontal has no x-intercept, unless it is the x-axis, and then again, you have an infinite number of x-intercepts. The equation of a horizontal line is of the form y equals k, where k is some constant. Note there is no x in the equation. When graphing a special case, it is easiest to go back to the most basic method for graphing equations, which is make a table. All right, so let's go ahead and look at some examples of this. Example A, we have x plus 2y equals 0. And as I said, the first thing that I'm going to do is make a table. So I'm going to have my x and my y. And for this one, let's start by plugging in 0 for x. If I plug in 0 for x, I get 0 plus 2y equals 0. My x term goes away and I am left with 2y equals 0. From there, we can go ahead and divide both sides by 2. We get y equals 0. So even though this is set up for x and y intercepts based on the type of equation, the form of the equation that we're looking at, it makes no sense to plug in 0 for y, only because we're going to get 0 for x again. So from here, we want to pick another value. I'm going to pick 1, and it doesn't matter what variable you plug it in for. I'm going to plug it in for y. Why would I want to do that? The question. The reason is because which one is going to be easier to solve for? Is it easier to solve for x, or is it easier to solve for y? Well, for me, since there is no coefficient for the x, in order to solve for x, it just means I have to move this term to the other side, and I'm done. Whereas if you plug in for x, then you're going to have to move the x term, and then you're going to have to divide by 2. And depending on what numbers you picked, dividing by 2, you can get nice numbers, but you can also get fractions. And remember that we are trying to avoid fractions at all possible costs. So what I'm going to do is I'm going to take my 1 and plug it in for y. If we do this, we get x plus 2 equals 0, and I can subtract 2 from both sides, leaving me with x equals -2. Remember that in order to graph a line, you only need 2 points. If you want to find a third one, you can always pick some other numbers and plug it in for x or y. If you're going to plug in for x, I would recommend making sure that you pick numbers that are divisible by 2. When you divide by 2, you want to make sure it goes in evenly. If you're plugging in numbers for y, then it doesn't matter what you plug in, because all you're going to do is subtract. I'm going to stop with 2 points here, as that is basically the only thing that we need in order to graph this. So let's go ahead and graph this equation. If we graph this, we have our first point, 0, 0. In order to graph that, I'm going to start at the origin and not move left or right, not move up or down. And so my first point is, in fact, the origin. My second point, -2, 1, what does that tell me to do? This tells me I want to go left 2 and up 1. So if we do that, we get 2 to the left, up 1, and so I should be just above the x-axis in the second quadrant. Now that I have my 2 points, I can go ahead and draw my line and label. Now, depending on what kind of format you're using in order to graph these equations, this one really doesn't qualify as a special case. It only qualifies as a special case if you are graphing using intercepts. If you are graphing using slope and y-intercept or using tables, then it doesn't qualify as a special case, because you can still find the slope, you can still graph. But that is our first line. So now, let's go ahead and go down to example B. Example B, we have y equals -3. Now, for this one, the only way to graph this or to find points on this line is using a table. This one, you cannot solve it or find points using x-intercepts and y-intercepts, and you cannot use slope in order to graph this line. Notice that there is no x term, therefore we don't have a slope that we can go ahead and plug in. Now, making a table for this is actually going to be very easy. We don't have to do any computations. And so if we make our table, I have this. Pick some values for x. So 0, 0. Let's go ahead and plug in 0 for x. When x is 0, what is y? Well, according to our equation, y is -3. I do need another point in order to graph this. So give me another value of x, 2. If we plug in 2 for x, what is y? Well, it's still -3. X can be whatever it wants, and y is always going to be -3. So for instance, x can be -1,225,497.8 88888888888888888 times pi. And y will be -3. So, for instance, we can also say x is -1. I'm not going to try to graph that long number that I said because I don't even know what I said. But here you have at least 2 points in order to graph. And the important thing to remember is that y is always going to be -3. So if we graph this, let's see what it looks like. For the first point, we're going to go ahead and plot this. We have 0, -3, which means that I'm going to start at 0. I do not want to go left or right. I just want to go down 3. Where are we going to end up? We're going to be below the x-axis, 3 below the x-axis. For the second point, we have 2, -3. This tells me I want to go right 2 and down 3. So if we go right 2 and down 3, we will be down in the 4th quadrant, 2 to the right, and 3 down. For our last point, -1, -3, we're going to go to the left 1 and down 3. We end up down in the 3rd quadrant, somewhere right around there. And now we can go ahead and draw our line. We can label some of our points here. We have 2, -3. We have 0, -3. We have -1, -3. And we're done with the problem. So all horizontal lines will be horizontal, but also their equations will always be y equals some constant. So now let's look at example C. Example C, we have x equals 5. So again, I'm going to make my table. This is also an example of one that you have to use tables. You cannot use xy intercepts. You cannot use slope and intercept. And so the only way to do this is using a table. And this is going to be very similar to the previous problem. So here's the thing. When x is 5, y equals 0. Hopefully everyone's okay with that, because if we look at this point, is x equal to 5? Yes, it is. So it is a point on the line. So what are some other points on the line? Well, when x is 5, y is equal to 2. For this point, is x equal to 5? Yes, this is a point on the line. Let's come up with a third one. When x is 5, y is -4. Looking at this point, is x equal to 5? Yes. So for vertical lines, or for when we see equations like x equals 5, all we have is the restriction is x has to equal 5. Y can be whatever it wants. So for instance, 5, 1,227,445 square root of 8 times pi would be a point on the line. So let's go ahead and graph this and see what it looks like. If we graph this, we have to start off with the point 5, 0. This tells me I want to go 5 to the right, and I do not want to go up or down. So if we plot that, we're going to go 5 to the right. We will be on the x-axis. For our second point, we have 5, 2. This tells me I want to go 5 to the right and 2 up. That is going to be 5 to the right and 2 up. We will be above the x-axis in the first quadrant. And for the last point, we have 5, -4. In order to plot 5, -4, I want to go 5 to the right and 4 down. So we'll be down here somewhere. We have our 3 points. We can now draw our line through these points, and we have a vertical line. We want to go ahead and label these. And we're done with the problem. Note here that vertical lines always have an x-intercept equal to whatever the number was. But note that this line will never go through the y-axis. And that's the one thing that all of these lines, these special cases, have in common, is that they only go through the axes at one location, where it's either the same point for the x and y-intercept, like in our first case. Our second case had a y-intercept but no x-intercept. And our last case had an x-intercept but no y-intercept. No matter what, when you graph a line, you have to have at least one intercept. You will cross the x-axis or the y-axis. You cannot get around both of them. So graphing special cases, when will we see this again? In later math classes, you will discuss a concept known as asymptotes and lines of symmetry. These lines are many times horizontal or vertical lines. So now try the following problems on your own and bring your solutions to class along with any questions that you have. At this point, if you will go ahead and pause the presentation so that you can go ahead and work on these. As soon as you are done, go ahead and unpause so that you can move on to the next slide. As part of your notes, please go ahead and answer the following questions and bring to class. How confident are you with the material presented? What from this section needs to be explained further? And how much more practice do you need to be comfortable with the topic?